Hey everybody, this is Prometheus Education, giving you guys a quick video on how to make your very own game controller for your PC computer. So, this game controller can have an analog joystick, so you can have buttons, you can play emulators, you can play any video game you want that accepts game controller interface, and you can even use the same technique to emulate a keyboard so you can play your first-person shooter with your homemade game controller. Now, the idea of this came from a long time ago, but using the PSOC 5LP, the concept is now a reality. This user here, GJL, made this awesome example of this USB HID, that's human interface device, game controller. I took that, so this is the post here, you can see the URL, don't punch it in, you can just look up this user. I took this example project, learned how he was making the USB HID descriptor, and made one here that's ground up. Now, if you want to make this project yourself, all of the hardware that you need is in the description, and a link to my GitHub page is also in the description, so you can just build this exact project. It's in there exactly as you'll see it today. So, of course, on Cypress, first thing you have to do is assign all of your peripherals. In here, as I know it's kind of an eye chart, let me just go ahead and enlarge this. We have an analog to digital converter for measuring the X and Y axis of a joystick. Joystick has up and down and left and right axes. You also have all the buttons. I have named the buttons after the Super Nintendo controller because that is what I'm going to emulate. I also have a debug channel on UART so I can stream out all of the data live from my joystick. Most of that's just to figure out what's broken about it as I'm developing it. And of course you have one more peripheral, that's the USB interface. So this is the most important part. Everything here is pretty bog standard except for this USB interface. So first thing you have to do, give yourself a vendor ID, a product ID, give yourself a manufacturing and product string, this Prometheus Education Homebrew joystick. In your configuration descriptor, set your power level, config string, blah blah blah. All of your here's the most important part here is that your class needs to be an HID class. You cannot assign these. You have to assign an HID report to these, but you can't do that until you've actually made your HID report. And of course, here's your endpoint descriptor. Endpoint number, so we only have one endpoint here. Endpoint is sort of a description of the data that's going to get sent over USB. So there's usually an input for keyboards and mice, and there's an output for, say, your caps lock, scroll lock, or num lock LEDs on your keyboard. Let's go to the HID descriptor because this is the big one. Now, if you want to just replicate everything here, if you want to start from scratch, everything you see on the left here is exactly what you need. Everything on the right is just more details. So as I click on these, you'll see which ones I've chosen. I'll walk you through this as best I can. I'm new to USB HID descriptors. We're going to go ahead and instantiate this device, this endpoint, as a generic desktop control, specifically a joystick. Its collection method is going to be for the pointer mechanism. That's going to have the X and Y axis. Your logical minimum and logical maximum are the values that you're going to assign, the range of values you can assign to the X and Y axis. So we're saying we can have negative 127 or positive 127. The report size here is 8, so each of these reports is going to be 8 bits in length, obviously signed. And our report count is 2 because we only have the 2 axes to report. So if you want to increase the number of axes you have, let's say you want a throttle axis, and you want to do flight simulators, you would have a Z-axis and you need to increase your report count. Of course, input is now going to be set to variable. Down here we have the buttons, so we end collection for the pointer, and now we begin collection here. Well, we've already begun collection, but we go ahead and declare usage of our buttons. I have 8 buttons for A, B, X, Y, L, R, start, and select. I have my logical maximum is 0 or 1 because these buttons are either off or on. They're only 1 bit in length, and there's 8 of them because there are 8 buttons. Okay. After you've made this report here, pop into device descriptor, HID class descriptor, and assign your report. That's all you have to do. In your main code, this is what you're going to have to add. Now, I encourage you to grab the link from my GitHub and just use that to start with to get to know the code in detail. So I'm just going to go over this really quickly. I've got debug UART, you send USB report. So while I'm troubleshooting this, I send a full copy of the report over my debug channel, which is a side channel. It lets me, figure out what's wrong with the code. Reset USB report, that's not very important. It just assigns values to 0 for the entire USB report array. In other words, to reset it so I can populate it again. I've got, so here's my code proper. My main here, I'm going to start my debug channel. I'm going to start my analog to digital converter. My analog to digital converter is an 8-bit mode with a free running mode enabled, so I just have to start the conversion once. I'm going to go ahead and start the USB peripheral, declaring, I gotta remember what this input is. I always forget. You can look at the code for more details. But pretty much just start this device, enumerated 0, and then give it 5-volt operation. Wait for the configuration to finish. Pop down here, load the report. Go into our eternal loop. Wait for an acknowledgement from the computer. So USB is set, the pace of a USB communication is set by the host device. So we're waiting for the host device here. We're going to reset the USB report, so set all the zeros. We're going to gather our analog data and do our bit shifting and do our mathematical manipulations on it. We're going to go ahead and write the contents of each of the buttons. So we're going to read the A, B, X, Y buttons. We're going to assign them to the bit field in the array. All this becomes much more apparent when you look at the code in detail. So again, I'm just going over it quickly. And then we're going to go ahead and report it. So we're going to say if our report is empty, then go ahead and send the report out. We're going to send the debug report over the debug channel and then send the report out to the USB. And that's honestly it. If I want to see what's going on, I'm going to open up Teraterm and look at my debug channel. Spitting out gibberish because I need to change my baud rate to 115 to 100. There we go. There's my debug channel. I've got my controller. I'm going to go ahead and just go left. There we go. Okay. Back to center, right, center, up, center, down, center. And let's do some loop-de-loops just for the fun of it. I've got every button. So here's select, start. I've got B, A, Y, X. And I don't actually have any LNR buttons, so that's pretty much it. Thank you guys for... here's a pretty picture to look at. Thank you all for watching, and hope you enjoy it. Find my GitHub. Go ahead and make your own game controller. You really only need a few parts and pieces, and again, they're in the description. So, hey man, learn more, make more. Have a good one.